All right, the best line fits. Oh, wait, best fit line. Either way, the line that best fits something. Or the fit line or the line fit, it doesn't matter. It's the same thing. Moving on. Okay, so we're going to talk about the best fit line. So this is a line that is very close to most of the data points. Notice that we said data points, not the line. When you're given when you're getting points of data, you're getting the dots on the graph rather than a line that's already perfectly made, like a linear equation. So this is why this is a little different. This is more on the stats side of things rather than the other way, or rather than just a linear equation like we've been doing at times. So it would look something like this. The blue dots are all different data points. So somebody took data of whatever this is, and then they kind of put one as close as they could through the middle. There are ways to do this on a graphing calculator, but not on a regular calculator. And sometimes you just take the first dot and the last dot, and that's kind of where you pick. I say there are exact ways to do it, but it doesn't have to be an exact science. It just kind of needs to draw through the middle and be able to say, you know, positive, negative correlation, no correlation, kind of thing is what it's going for here. All right, so example one. The table that shows the amount, this table shows the amount of land in the U.S. farms from 1980 to 2000. Make a scatter plot and draw a best line or best fit line for the data. So we can look, we have 1980, there was this million acres of land, and it keeps going down and down and down. Yes, that's my cats fighting for no good reason. Apparently one of them looked at each other funny. Oh yeah, cat fight, literally. Literally. Moving on. So what that would look like is you would make a graph. Notice they put this little junk here, so they didn't have to do 0 through 100 there. You're allowed to do that if you so desire. So then they put each of the years for each data point. So then they're going to graph each point. 1980, there was that many approximately. I don't like their giant ovals that they use, but these kind of go in a fairly straight line. And then they drew a line through them to get your line best fit. All right, use your best fit line to predict the amount of land in 2010. So they just extended it out a little ways. So you extend the line so that you can find the y value for the x value in 2000 or 2010. The y value for about 2010 is approximately 892, though if you had said 900, I'd have probably accepted that too. So the prediction is approximately 892. I don't know how they came up with that exact number, but sure, why not? All right, your turn. Go. More random cat noises. Fantastic. All right, make a scatter plot and then draw the best fit line. So I'm going to make a kind of a rough one over here. I'm sure they're going to do a better one over here once we get going a little farther. So I'm just going to go 99, 98, 99, and so on. And we'll just start at 200. So we'll put the little thing here and go 200, 300, 400, 500. Looks like the size we're going to go. So 98, there were like a little over 200. 99, they were almost 300, almost 400. Oh, and then it kind of drops down and a little more then, so it kind of arcs a little bit. So to draw our line best fit, it's going to be a little below and above some of them. So our line would look something like this. Okay, they were fairly close to what I put there. Use the line best fit to predict the number of laptops in year 2003. So 2003 looks like it's approximately here, at least by this fit data. So 700 or 650-ish. Yeah, about 650. I wonder what the actual number was since that was long enough to have that data. Moving on. All right, this scatter plot shows the number of milk cow operations in New Mexico from 75 to 99. Write an equation in slope-intercept form for the line best fit. All right, so first you have to select 2 points and find the slopes. We're using that slope form, or slope point. They chose 15, 1200, 15, 1200, because that's actually a line that, or pretty close to the line there that was best fit. And then they chose 2900. And they just kind of guesstimated that it was at 900 here. So again, it's not an exact science. And you're just trying to kind of figure the best numbers that you could have done. You might have even done this 1400 and 1200, but it's not quite on a 45-degree angle. Would have been a little low if you'd gone that way. So that's kind of, you're just trying to get one that's close to it. So they use these points, and they're going to put that into slope form. So our definition of slope, and we're going to subtract them out. And simplify it, comes out to -60. So next we're going to find the y-intercept to be able to have a slope formula. Well, we take our slope-intercept form, and we're going to punch in this for our slope, and we're going to pick one of these 2 points that we picked to find the y-intercept. Punch those in, multiply them out. Oh, and they just simplified it all out for us. So they multiplied those together and then subtracted them to the, or added them, sorry, because it's negative, added them to this side. Now we have a slope and a y-intercept. We can make a y equals mx plus b. So we write the equation, slope-intercept form. We put in 60 for our slope, 2100 for our y-intercept, and we have an equation. All right, so predict the number of milk cow operations in 2005. All right, write the equation for best fit line. We're then going to replace it with 30. Now they get 30 from the original, or have to go way back here. So they went 5, 10, 15, 20, they go 25, 30. Because we said 0 to 1995 was 0 after 75. That's how they came up with that number of 30. As long as we keep with the same format numbering, you're okay. So that's where they got 30 from. Multiply it all out, you get it to about 900 or about 300 milk cow operations. All right, your turn. Go. All right, the scatter plot shows the heating bill for the month of January and for different sizes of houses, square footage, and their heating bill in dollars. That's expensive. So we need to, oh, I told you to go and I didn't give you the equation. Now you can try it. All right, so write an equation in slope-intercept form for the best line fit. Well, my best line fit's going to be probably through there-ish. So I like that point for sure. And maybe that point. We might have to guesstimate it just a little bit below that. So I'm going to say 1500, 100. It's going to be 1 point. 1500, 100. Let's just call that 200, 1300. Or 3000 and 200. So we'll put those in. So we're going to call this my Y2s. So 3000 minus 1500 over 200 minus 100 gives me 1500 over 100, which would give me 15 over 1. So that gives me a slope of 15. Let's take one of those numbers here. So I'm going to take y, it's going to be, let's take the smaller one, 1500 equals 15 and then 100. Is that right? Equal plus b. Wow. So sample answer. Wow, my sample answer is way off there. So if yours is a lot closer, that'll be great because this is going to be 1500. So I'm actually going to end up with a little higher than that. So mine ends up being 0 because I'll subtract 1500 from both sides. That'll give me 0 equals b. So I actually come out with a y equals 15x. Wow, what a difference. That's fascinating. 1500, 100, 1300, or 3000, and 200. I think I did all the numbering right. So we come out with little different answers here, and that's always possible. All right, so the equation I came up with would have been, approximately this. And again, this is not an exact science for these line best fits. Yeah, so if you're close to this number, I'm okay with it. Oop, got to keep going. So I would take 4,100 square feet and put that in for my x. Did I flip these? Y is 100. Ooh, let's see if that's what I did. See if that'll make it a little closer here. Let's try it out. So my y is 100. Well, let's see, and then I would have done these backwards too. Let's reverse. Let's just do it all over again. All right, so my y1, so let's do those same two numbers, 1,500 and 1,500 and 100, and then 3,000 and 200. Sorry if you feel like I'm wasting your time, that's okay. So my y's are going to be rise, so I'd have 200 minus 100, and then 3,000 minus 1,500 is going to give me 100 over 1,500. That's a little closer. That'll give me 1/15. All right, so that's 0.067x is what, that's a little better. So when we put that one in, let me speed through. Okay, so we're back. So I sped through it, punched in the numbers. I actually came up with almost 0, so negative 0.5. Not much difference for my plus b. So I have y equals 0.067x plus a negative 0.5. That's what mine came up to. We're going to put in 4,100. Punch that all in. I get 274.2, which is fairly close to 308. So if you're within that many dollars and your equation's within fairly close, we'll call it close enough and won't mark you off for it. And that's all we got. See you in class.